10-1 to 10-4, we're just going to do as a quick review. This section, 10-1, Pythagorean theorem, you do already know. Pythagorean theorem says c squared is equal to a squared plus b squared. Your c is your hypotenuse of your triangle. A and b are the legs. So when you get into geometry, we'll say the hypotenuse squared is equal to the sum of the legs squared. So to use that, we will go through a triangle. Your hypotenuse is 17, the leg is 8, and the other leg is x. So you go 17 squared equals 8 squared plus x squared. 17 squared is 289. 8 squared is 64. X squared remains x squared. So then we subtract 64 from both sides, and we get 225 equals x squared. So when we're solving this part, again, you have to take square root of both sides to get down to single x equals square root of 225 is 15. So now we've completed our problem with the Pythagorean theorem. In this section, they always also do the converse of the Pythagorean theorem. And the converse of the Pythagorean theorem says if c squared equals a squared plus b squared, then the triangle is a right triangle. So you're going to be doing the same thing in this section as you did before, but you're going to leave out the equal sign. So if you're given three sides, you don't know which one is your legs, and hypotenuse until you look at them. Your hypotenuse is always your longest side. So then we go hypotenuse squared. We leave the spot for the equal sign because we don't know that they're equal. The other two legs are 12 squared and the 60 squared. Square 61, and you have 3,721. 12 squared is 144. 60 squared is 36. Add the 144 to the 3,600 and you get 3,744. Those numbers are not equal, so it is not a right triangle. In 10-2, we are simplifying radicals. So we need to look at the multiplication property of radicals, and it says the square root of a times b is equal to the square root of a times the square root of b. So what we're going to be doing is simplifying our square roots. An example of that, square root of 200 is equal to the square root of 2 times 100. We can put the square root over each number. I can't take the square root of 2 without a calculator, and we are not doing that in this section. We're just leaving it. Square root of 100 is 10. So we write 10. The square root of 2, because we can't simplify it, stays. If we have some variables in there, we can do the same thing. We separate them up. 20 is 4 times 5. X to the 5th is x squared times x squared times x to the 1. We went over exponents in a previous chapter. Square root of 44, I now know, is 2, so I can write that down. Square root of x squared is x. Square root of this x squared is an x. So I've taken care of the 4, the x squared, the single x, and now I have 5 left and an x left. I can't take the square root of 5, and I can't take a square root of this x, so they stay under the radical sign. The numbers in front get multiplied, so I have 2x squared times 5x. We can also use the division property of radicals. In the division property, we can separate up our division problem into two separate radicals. So if we have the square root of a divided by b, I can separate it up into square root of a divided by square root of b. So in doing that, my square root of 49/81, I can separate the square root of 49 over the square root of 81. Square root of 49 is 7, square root of 81 is 9. If you can simplify the square root before starting, please simplify first, and then take the square root of each. Now sometimes when you take the square root, you end up with a square root in the denominator. So that is when we have to rationalize the denominator. All this means is get rid of the denominator. So if I have 7 square roots of 3x to the 5th divided by 2x squared, and that's all under the square root sign, I want to simplify the x to the 5th divided by x squared. 5 minus 3 gives you the 5 minus 2 gives you the 3. That stays in the numerator. I can't simplify the 3 halves at all. So I now, well, the 7 just sits outside. I can put the square root over the 3x cubed and the square root over the 2. Because there's a square root in the denominator, I need to eliminate the square root. So I multiply by itself, which is square root of 2. Because I have to multiply by 1 always with a fraction, I multiply the numerator and denominator. So the numerator, that square root of 2 gets multiplied by the 3, and I get 6. X squared times x gives me back to that x cubed, so I can simplify that numerator and bring out this x squared. Square root of an x squared is x, and then the 6 and the x, single x, stay underneath. The denominator, because I had a square root of 2 times square root of 2, is just 2. So once it's simplified, that 2 just goes on the denominator. And that is rationalizing the denominator. 10-3 deals with operations with radical expressions. You add them the same as you would like terms. So, if I had a square root of 28 minus 5 square roots of 7, they aren't the same, but square root of 28 is not simplified. So always simplify first. And the 28 is 4 times 7. Square root of 4 is 2. Square root of 7 I don't know, so it stays. So now I have 2 square roots of 7 minus 5 square roots of 7. If you need to, you can look at that as 2x minus 5x. So 2 minus 5 is negative 3. Since they have both the same term, identical, just like we did with the x's, we just subtract that coefficient in front, and 2 minus 5 is negative 3, just like we would in the x's. If they have distributive property and FOIL, we do the same things that we did before. Distributive property, again, you want to always simplify. So we have the square root of negative 12, and we have 4 minus 2 square roots of 3 in parentheses. So if we're subtracting a square root of 12, that can be simplified. 12 is 4 times 3. This stays the same. Square root of 4 is 2, so we get negative 2 square roots of 3. Now that is all my numbers are simplified, I can do the distributive property. So that was taking this number times the 4, and then this number times the negative 2 square roots of 3. So negative 2 times 4 is negative 8. The square root of 3 sits next to it. Negative 2 times negative 2 is positive 4. Square root of 3 times square root of 3 will give me 3. Again, square roots cancel each other when you have a number underneath squared. So that gives me negative 8 square roots of 3 plus 4 times 3, which is 12. Those are not like terms. I can't simplify any further, and I just end up with negative 8 square roots of 3 plus 12. When we FOIL, that was always taking the first term times the first term over here. Then we did the outer terms, inner terms, and last terms when we multiplied. So when we take our first term, square root of 6 times square root of 2, our outer term, square root of 6 times negative 2, we put the negative 2 in front, then the square root of 6. Square root of 3 times square root of 2, write it down. Square root of 3 times negative 2 would be a negative 2 square roots of 3. Now we can simplify. Square root of 6 is 2 times 3 times the square root of 3. My negative 2 square roots of 6 stays. Square root of 3 times square root of 2 is square root of 6. And this minus, or negative, 2 square roots of 3 stays the same. So when we simplify, here square root of 2 times square root of 2 is 2. The square root of 3 stays. This one, negative 2 square roots of 6 plus 1 square root of 6 would give me negative 1 square roots of 6. Again, the 1 we don't have to show, but it is there in front. Bring down the negative 2 square roots of 3. So now 2 square roots of 3 minus 2 square roots of 3 cancels, and I just end up with negative square roots of 6. In 10-4, we are going to be solving radical equations. So we solve equations with radical signs in them, just like we do any other equations, except there's one more step to them. First thing you always want to do is isolate the square root sign, or the square root term. So if I have square root of n minus 3 equals 6, I want to get this term by itself. So I'm going to add 3 to both sides. Make sure you're on opposite sides of the equal sign. This then minus 3 and plus 3 cancels, and I get square root of n equals 6 plus 3, which is 9. And this is where it's different. I'm not done now. I have a square root in here. So now I have to square both sides of the equation. So when I square this whole term and this side, square root of n times square root of n is n. 9 squared is 81. And now my equation is complete. If you have a little more complicated equation, again you want to isolate the square root term. So I have to get rid of the positive 2 by subtracting 2 from both sides. And when I do that, I get the square root by itself of 10b plus 6 equals 6. Again, now I have isolated the square root term, so I can square both sides. And when I square the square root, it cancels the square root and just leaves me with 10b plus 6 equals, and 6 squared is 36. Now I have to solve this equation, so I add 6 to both. Sorry, it was plus 6, so I subtract 6 from both sides to get 10b equals 30. To get b by itself, I have to divide by the 10. And then I have b equals 3. Those are the 4 sections that you are dealing with today.